In this video, we'll talk about partial derivatives of functions with more than one variable. So let's find the first partial derivative of a following function. F of xy equals 3x squared plus 4y cubed. So we want to find df dx. So that's the partial derivative of f with respect to x. What do? Well, we consider the y a constant, and so we differentiate with respect to x. So 3x squared prime, it's 6x, and then 4y cubed prime, it's 0 because we consider this a constant. And the constant prime is 0. df dy is the derivative of f with respect to y. So this time we consider this a constant. So 3x squared prime, or 3x squared differentiated with respect to y, is 0, and 4y cubed differentiated with respect to y is 12y squared. Another notation for the derivative of f with respect to x could be f and then x underscore, and the same f underscore y. Let's do another problem. So let's do f, the first derivative of f with respect to x, so df dx equals, and we want to differentiate cosine of xy. So let's remember that cosine of u of x, right, prime, is negative sine of u of x times u prime of x. So in this case, our u of x is xy. So we get negative sine of xy times xy prime, but that means differentiate with respect to x. So we get negative sine of xy times xy differentiated with respect to x is the same thing as if we had to differentiate 2x with respect to x or 3x. So it would be just the constant. And because we are differentiating with respect to x, y is considered the constant. So times y, or negative y sine of xy. And let's do fy, or df dy. As you can notice, we also write the d as a curly d to emphasize that we are differentiating, we are using partial derivatives. So df dy, it's again negative sine of xy, but this time times d dy of xy. So we get negative sine of xy times, and the derivative of xy with respect to y means just the constant, which in this case it's x. So it's negative x sine of xy. So when we differentiate with respect to x, we consider y a constant. When we differentiate with respect to y, we consider x a constant. And we can do the third problem. The third problem is we want to do the derivatives of the function e to x squared y. So fx is the derivative of f with respect to x, which is e to x squared y times the derivative with respect to x of x squared y. So is equal to x squared y times, if we differentiate with respect to x, y is a constant, so we get 2xy, or 2xy e to x squared y. And fy is the df dy, which means e to x squared y times the derivative with respect to y of x squared y. So this time we differentiate with respect to y, so y prime is 1, so we end up just with a constant. So it's e to x squared y times x squared, or x squared e to x squared y. Let's solve another problem. Let's say we have the function h of xy is x cubed plus xy squared plus 3, and we want to find this second order partial derivatives. So we want to find hxx, hyy, hxy, and hyx. So hxx means the derivative of x, the derivative of h with respect to x twice. So first we want to find hx. So from here, hx is the first derivative of h with respect to x, which is 3x squared plus y squared. And hy, because we'll need that later, is 2xy. So hxx means differentiate with respect to x hx, which is 3x squared plus y squared. So when we differentiate this with respect to x, we get 6x. Hyy is the first derivative of y of h with respect to y differentiated again with respect to y. So d dy of hy, we found it, it's 2xy. So if we differentiate this again with respect to y, we get 2x because we consider y is the variable and x is the constant. So y prime is 1, so we get just a 2x. Now hxy means calculate the first derivative of h with respect to y, x, and then differentiate with respect to y. So hx is, so we want d dy of 3x squared plus y squared. So that's 2y, right? Because this is a constant prime, it's 0, and then y squared, differentiate with respect to y, it's 2y. And the last one, hyx, it's hy differentiated with respect to x. So we have d dx of hy is 2xy, and when we differentiate this with respect to x, we get 2y. So we all also want to note that hxy equals hyx. So the partial derivatives, the mixed partial derivatives are equal to each other.